All right, Unit 4 Practice Exam Version B. Question 1 here, this comes from Section 5.2, Systems of 3 Equations and 3 Variables. So it mentions 3 types of gas. We have regular, performance, and premium right here. So we need to make 3 equations for our 3 variables because the question is how many gallons of each type were sold that day. So if they're asking how many gallons, that's going to be how we define our variables. So let's say let X be number of gallons of regular sold on that particular day. We can let Y be number of gallons of performance sold on that particular day, and then Z be the number of gallons of premium sold on that day. So said on this particular day there were 6,500 gallons of gas sold, and that 6,500 gallons of gas is going to come from a combination of all 3 of those. So that's going to be our first equation. Number of gallons of regular plus the number of gallons of performance plus the number of gallons of premium is equal to 6,500 gallons total, and it said that the amount of money made for that day was 20,050 cents. So that's our second equation. If it's $3 times the number of gallons of regular plus $3.20 multiplied by the number of gallons of performance plus $3.30 times the number of gallons of premium is equal to $20,050. Now these kind of phrases here towards the end can be a little confusing. It's talking about regular and premium, so that's X and Z. 3 times as many gallons of regular as premium were sold. So right now, X is 3 times as big as Z because it says 3 times as many gallons of regular. So X is 3 times bigger than premium. So in order to make these equal to each other, I need to multiply premium by 3 so that they're equal to each other. Because like I said, X is already 3 times as big as Z according to this. So in order to make them the same, Z needs to be multiplied by 3. So X equals 3Z, or if we get them on the same side, X minus 3Z is equal to 0. So we have our equations set up. What we need to do now is solve the system of 3 equations for X, Y, and Z. Now notice that this equation already has Y eliminated. So I'm going to take these top 2 equations and eliminate Y, which means I'm going to need to multiply that top equation by negative 3.2. So this top equation, when multiplied by negative 3.2, is negative 3.2x minus 3.2y minus 3.2z equals 6,500 multiplied by negative 3.2, which is negative 20,800. Now this middle equation is going to stay the same. If I add these together now, y is going to cancel. 3.2, negative 3.2, x plus 3 is negative 0.2x. And then here, negative 3.2z and 3.3z is 0.1z. And then 20,800, negative 20,800 rather, minus 20,050 is negative 750. Now, I'm not thrilled to have decimals here, so I'm going to multiply that by 10 just to get rid of the decimals. So that's going to become negative 2x plus z equals negative 7,500. Now I'm going to take this equation and combine it over here. And multiply it by 2. Cancel that. This becomes a negative 6z, and then that's a 1z, so that becomes negative 5z. And then this is negative 7,500. So divide by negative 5, and we get z is equal to 1,500. So this is 1,500 gallons of premium. Now, according to this, 3 times as many of that was sold for regular. So 1,500 times 3 would be the number of regular gallons sold. So that's 4,500. And there were only 6,500 gallons total sold. And so if we add 4,500 plus 1,500, that's going to tell us how much remains for performance. So if we add, like I said, if we add these two, this is 6,000 gallons. And there were only 6,500 gallons sold total. So the amount remaining for performance has to be 500. Okay, question number 2. I'm going to first, since I notice right here that we have negative y and positive y, I'm going to take these top 2 equations and eliminate y. So since we eliminated y in the first step, for the next step we need to choose 2 more equations and eliminate the same variable. So I'm going to choose the top and bottom equation. And since we have a 4y, this needs to be a negative 4y. So this top equation needs to be multiplied by 4. So that top equation becomes 4x minus 4y plus 20z equals negative 8. Bottom equation stays the same, 2x plus 4y minus 2z equals 8. So if we eliminate y, we end up with 6x plus 18z equals 0. So now we combine these 2 equations, the result from step 1, which was 3x plus 9z equals 0, and then the result from step 2 was 6x plus 18z equals 0, and then we eliminate one of the variables. So if I multiply the top equation by negative 2 and add these together, this becomes a negative 6. So x eliminates. This becomes a negative 18. So z also eliminates, which means we have 0 equals 0. Now what we learned in class, that's an indication of infinitely many solutions. So what we do is represent the solution as a parameter, using t as the parameter. So the way we start is we let z equal t, and then we work our way backwards through the problem. So if we let z equal t, now we can solve for x, and once we find x and z, we can come back to the original equations to find the value of y. So I'm going to take this version of the result from step 1, 3x plus 9z is equal to 0. 3x plus 9z is equal to 0. We make this substitution here, that z is equal to t, so this becomes 3x plus 9t is equal to 0. If we move the 9t to the other side, we get 3x equals negative 9t, divide by 3, and x equals negative 3t. So we have what z is equal to, we know what x is equal to, we're just missing y. So I'm going to take the middle equation from the original three equations, 2x plus y plus 4z is equal to 2, and now make the substitutions for x. And then for z, we substitute t. And we can combine these two like terms to negative 2t. And then to get y by itself, we add the 2t to the other side. So now we have the value of all three variables. We have the value of x, we have the value of y, and we have the value of z. So those are represented in an ordered triple, negative 3t, 2t plus 2, and t. Partial fraction decompositions are from section 5.3. The first step was to write the form of the partial fraction. The form of the partial fraction is primarily dictated by how many factors there are in the numerator. Since there are two factors in the numerator, there are going to be two partial fractions. Now, step 2, once we have the form of the partial fraction, what we need to solve for is a and b. So what we do next is we want to multiply both sides of this equation by the lowest common denominator so that we can solve an equation with no fractions. So if we multiply this by the common denominator, and then do the same thing over here, multiply this by the common denominator, then they cancel out there. Here we're going to have the common denominator is going to multiply to this first fraction. The x minus 5s would cancel, so x plus 2 multiplies to the a. And when it multiplies to the b partial fraction, now the x plus 2s would cancel, so x minus 5 multiplies with b. Now, one way we can solve this, since the values of x at this point are irrelevant, we're solving for a and b, we can choose values to plug in for x so that we can isolate either a or b. So I call these convenient values. If we let x equal negative 2, for example, negative 2 plus 2 is 0. 0 times a means a is gone from this equation to allow us to solve for b. So I'm going to let x equal negative 2, plug it in for all variables of x. So this is negative 14 plus 7, which is negative 7. Here we get 0. Here we get negative 2 minus 5, that's negative 7, times b is negative 7b, therefore b equals 1. Now we still need to solve for a, so I'm going to do it one more time, but this time I'm going to try to cancel b so that I can solve for a. So I'm going to let x equal 5. So we get 35 plus 7, which is 42. 5 plus 2 is 7. 7 times a is 7a. And then here, 5 subtract 5 is 0. So b disappears from that equation. Divide by 7 and we get a is equal to 6. So then we can write our partial fractions using the values of a and b. 6 over x minus 5 plus 1 divided by x plus 2. Question 4 is from section 5.4, solving a nonlinear system of equations. So this bottom equation is a linear function. It's going to be a straight line. X squared plus y equals 9 is a quadratic, so its graph would be a parabola. So we need to find where this line intersects with this parabola. So notice we have like terms, and one of them is negative, one of them is positive. So if we were to use the elimination method, the y variable eliminates. Now these are not like terms, so they cannot combine into one term. So we leave them as x squared plus x equals 6. We can solve by factoring. And then find the value of x equals negative 3 and x equals 2. So we need to find the corresponding y value for each x value. So when x equals negative 3, I'm going to use that bottom equation, which says x minus y equals negative 3. Well, if we make the substitution for x right there, negative 3 minus y equals negative 3, we get y is equal to 0. When x equals 2, I'm going to use the same equation, x minus y equals negative 3. Now we plug in a 2 there for x. 2 minus y equals negative 3. If we subtract 2 and then divide by a negative 1, so we have negative 3 comma 0, and here we have 2 comma 5. Question 5 is from section 5.5, graph the solution set for a system of inequalities. So we need to graph both of these graphs on the same coordinate plane here. And since these both have x squared variables and y, these are going to be parabolas. Parabolas are easiest to graph when the y variable is on one side of the statement. So I'm going to move the 2x squared by subtracting it. So this top inequality is going to be y is greater than negative 2x squared plus 4. For the bottom one, I'm going to subtract the x squared. So we have negative y is less than or equal to negative x squared plus 8. And then one more step, divide by negative 1, so y is greater than or equal to now. Because remember, when you divide by negatives, you flip the direction of inequality. It's greater than or equal to x squared minus 8. So both of these are parabolas. This one's been moved up 4, flipped upside down, and a little bit skinnier. This one's down 8 units because this minus 8 is outside the function, so it's a vertical shift down 8 units. This is a vertical shift up 4 units. Let's do this top one. So the vertex of a parabola is at 0, 0 unless there have been transformations that move it left, right, or up and down. There's nothing inside the function that's moving it left or right, but the plus 4 moves it up 4. So it has a vertex at 0, 4. Now we need to find two other points on two other points on this parabola. So if I plug in a 1 for x, then 1 squared is 1. 1 times negative 2 is negative 2. Negative 2 plus 4 is 2. So 1 comma 2, and then we can use symmetry to negative 1 comma 2. And because there's no line under the inequality, it's not an equal to inequality. That means this is a parabola that uses dotted lines. And then when we shade, the safest way to decide where to shade is to use a test point. I'm going to use 0, 0. And I'm going to plug it into the original form of the inequality. If x is 0 and y is 0, then we get 0 plus 0. And then we have to decide, is 0 greater than 4? Well, obviously it's not. 0 is not greater than 4. So what that means is the test point we chose, since it did not satisfy the inequality, the test point should not be in the shaded area or the solution set for that inequality. So with parabolas, it's either inside or around the outside. Since our test point didn't work, we're shading around the outside. So for this parabola, we shade around the outside, like this. Okay, for the next parabola, it's moved down 8 units, but it's facing up. So the vertex is down at 0, negative 8. If we plug in x equals 1, 1 squared is 1, 1 subtract 8 is negative 7. So when x equals 1, y equals negative 7. And since it's an equal to inequality, it's a solid line. And then to decide where to shade on this one, we use the same test point of 0, 0. So we're either going to shade inside the parabola or outside, depending on if the test point satisfies this inequality. So if x and y are both 0, we have 0 subtract 0, which is 0. And 0 is less than 8, less than or equal to 8. So we're shading inside the parabola. So I'm actually going to extend these lines just a little bit. So if we shade inside this parabola, like that, the solution set for the system of inequalities is the area that contains both of the shaded regions. Now you can see this region here has only the blue. This region here and here has only the red. But if you look here, down to this corner, around the top of that parabola, down into this corner, this area here contains both of the shaded regions. So that would be the solution set. Here, up around the top, down into that corner. This is the area that contains the shaded regions of both graphs. So that's the solution set. The directions of the problem are to graph the solution set. So that's what that is. Be sure to find the location of the vertices. The vertices are intersection points around the boundary area of the solution set. So if you look here, we have a boundary area and the two graphs intersect here and here. So these two vertices, wherever these graphs intersect, we need to find the location of those two vertices. That's done by using techniques from section 5.4, systems of equations. So we need to turn these inequalities into equations. These are the original inequalities. I'm just changing the inequalities into equal sign. So we can solve this one using elimination method because y and negative y eliminate. These are like terms, so we can combine those into 3x squared. Divide by 3 and square root of 4, which means x is equal to plus or minus 2. So we need to find the y value for when x equals 2 and the y value for when x equals negative 2. So when x equals 2, I'm going to use this bottom equation right here. It says x squared minus y equals 8. So if you plug in that, 2 squared is 4 minus y is equal to 8. So this means y is equal to negative 4. When x equals negative 2, I'm also going to use that same equation, x squared minus y equals 8. Plug negative 2 in for x. Negative 2 squared is 4. So we also get y equals negative 4. So we have one intersection point at 2 comma negative 4, and then the other one is negative 2 comma negative 4. That's the location of both of those vertices. Okay, question 6. This is from section 6.1, Gaussian elimination, which is using a matrix to solve a system of equations. So it begins by forming the augmented matrix. And the techniques we talked about in class are the direction we had is this needs to be a 1, this needs to be a 0, and then this needs to be a 0. Once that's accomplished, this needs to be a 1, this needs to be a 0, and then this needs to be a 1. So it's about halfway done for us. This is already a 1, this is already a 0, so the next task would be to get this to be 0. So I'm going to multiply row 1 by negative 1, because that'll make a negative 1 right here, which I can add to row 3 to make 0. So that's going to look like this. Negative 1 times row 1 plus row 3 equals row 3. That's going to make a negative 1 plus 1, which is 0. That's going to make a positive 2 plus 1, which is 3. That's going to make a negative 1 plus 3, which is 2. That's going to make a negative 1 plus 8, which is 7. Now typically the next step would be to get whatever is here to turn it into a 1. Like if it were a 3 or a negative 7, what you would typically do is multiply the whole row by the reciprocal fraction. Like if it was a 2, you'd multiply by 1/2, or if it was a 5, you'd multiply by 1/5. Since it's already a 1, we don't need to worry about that. So now the next task is to get this to be a 0. So I'm going to multiply row 2 by negative 3, because what that'll put here is a negative 3, and then negative 3 plus 3 is 0. So that step's going to be negative 3 times row 2 plus row 3 is a new row 3. So that's 0 plus 0. That makes a negative 3 plus 3, which is 0. That makes a negative 6 plus 2, which is negative 4. And then that makes a negative 15 plus 7, which is negative 8. Now, technically, this is not row echelon form that we talked about in class. Technically, row echelon form, all of these should be 1s. But the bottom row is far enough along to where we can use the bottom row to solve for z. This negative 4 is a coefficient in front of z, so that bottom row represents the equation negative 4z equals negative 8, therefore z is equal to 2. If we use the middle equation, or the middle row rather, this represents the equation 1y plus 2z equals 5. So 1y plus 2z equals 5. If we substitute 2 for z, we get y plus 4 equals 5, or y equals 1. Now if we take this top row, x minus 2y plus z equals 1. So x minus 2y plus z equals 1. Make the substitutions. Y is 1, so negative 2 times 1 is negative 2. Z is also 2. So this gives us x is equal to 1. So the solution is x is equal to 1, y is equal to 1, and z is equal to 2. Now it's never a bad idea when you're using Gaussian elimination. When you have a solution, or what you think is a solution, check it in the original equations. If x is 1, and y is 1, and z is 2, then this is 1 subtract 2, which is negative 1. Negative 1 plus 2 is 1. Here we have 1 plus 2 times 2, so this is 1 plus 4, which is equal to 5. Here we have 1 plus 1, which is 2. 3 times 2 is 6, so 2 plus 6 is equal to 8. So it checks out in all three equations. Okay, question 7 is from section 6.2, operations on matrices. Part A is a 3 by 3 matrix, and B is a 2 by 3. So we don't have the same number of columns as the number of rows here. So A times B is not possible. Now B times A, matrix B is a 2 by 3, and matrix A is a 3 by 3. So those two inside numbers are the same. So B times A will work. So when matrix B is multiplied to matrix A, we're going to get a 2 by 3 matrix. This entry is row 1, column 1. So we need row 1 and column 1. So row 1 and column 1. So the first entry there is 1 times 2. So that's 2. And then the next entry is 2 times 1 here. So it's another 2. And then finally we have 0 times negative 2, which is 0. Now this entry here is row 1, column 2, so we still need row 1, but now we need column 2. So I'm going to use row 1, column 2 to get that entry right there. So 1 times 1 is 1. 2 times negative 1 is negative 2. And then 0 times 1 is 0. Now to find this entry, it's still row 1, but now it's column 3, so we need to use column 3 with row 1. So we have 1 times 5, and then 2 times 4, and then 0 times 0. All right, this entry is row 2, column 1, so now we need row 2, column 1. So that's going to be negative 2 times 2, negative 2 times 1, and 1 times negative 2. Now we have this entry, which is row 1, column 2, sorry, row 2, column 2. So row 2, column 2, so it's negative 2 times 1, and then negative 2 times negative 1, which is positive 2, and then 1 times 1. And finally, this last entry is row 2, column 3. This entry right here is row 2, column 3, so row 2, column 3. So it's going to be negative 2 times 5, and then negative 2 times 4, and 1 times 0, which is 0. So we have 2 plus 2 plus 0, which is 4. 1 plus negative 2 plus 0 is negative 1. 5 plus 8 plus 0 is 13. Negative 4 plus negative 2 plus negative 2 is negative 8. Negative 2 plus 2 plus 1 is 1. And negative 10 plus negative 8 plus 0 is negative 18. For part C, 2b means all of the entries of matrix B here multiplied by 2. So 2b becomes 2, 4, 0, negative 4, negative 4, and 2. And then similarly with 3c, that's all the entries of matrix C multiplied by 3. So that's 18, 6, negative 6, 12, 0, and negative 9. And then we're going to subtract. Now in order to add or subtract matrices, remember the two matrices have to be the exact same size, which these two are. So you simply subtract entries that are in the same spot, like this entry and this entry are in the same spot in each matrix, you subtract them. So you're going to get 2 minus 18, which is negative 16, 4 minus 6, which is negative 2, 0 minus negative 6, is positive 6, negative 4 minus 12, negative 16, negative 4 minus 0 is negative 4, and 2 minus negative 9 is 11. Question 8, solve the system of linear equations using matrix equations. This is from section 6.3. So we need to set up the coefficient matrix. And then find the inverse of the coefficient matrix. So it's 1 divided by A times D, which is 6, minus B times C, so that's negative 1. And then A and D change spots. And then B and C become the opposites. So this is going to become its opposite, which is positive 1, and this becomes its opposite, which is negative 1. So that's the inverse of A. So matrix equations, what that is, we have the coefficient matrix, we have a matrix containing the two variables, and then we have a matrix containing negative 1 and 12. So this symbolically is matrix A, this is matrix X, and this is matrix B. If we're going to isolate this matrix right here, then what we need to do is cancel matrix A. The only way to cancel a matrix is multiply by the inverse. on both sides. So that cancels there. So what we're looking for is A inverse multiplied by B. So we have A inverse. We need to multiply that by this matrix here. So we have 1/7. So that's the inverse of A. We're going to multiply that by this matrix -1, 12. So I'm going to leave the 1/7 to the very end and just multiply the two matrices together first. So this first entry here is row 1, column 1. So this is row 1, column 1. So this is -2 times -1, which is 2. And then this is 1 times 12, which is 12. The next one's going to be row 2, column 1. So this is -1 times -1. And then we have -3 times 12, which is -36. So that's 14. And -35. Now multiply by the 1/7, and we get 14/7, which is 2, and -35/7, which is -5. So this is what this matrix is equal to. So x is 2 and y is 5. All right, the determinant of matrix A. This is from section 6.4. So I'm going to copy this column to the right side and then this column to the right side of that. And then I'm going to multiply three different numbers. So I'm going to multiply these three numbers. So -2 times -3 is 6, and then 6 times -3, that's -18. And then I'm going to multiply these three numbers. 0 times 2 times 2 is 0, and then multiply these three numbers. -1 times 1 times 2 is -2. Those I'm going to add. Now I'm going to multiply three more numbers here. -1 times -3 is 3. 3 times 2 is 6. Here, -2 times 2 is -4. -4 times 2 is -8. And here, 0 times 1 times -3 is 0. All of those are going to be subtracted. So -18 plus 0 plus -2 is -20. Minus 6 plus 8. That's -26 plus 8. That's -18.